Here we have question 2, and one of those questions where when you're revising it throws you off straight away because there's just so much information. Too much information for a math student. Okay, but we'll break this down. Okay, so you've got a small boat S drifting in C, models a particle moving in a straight line with a constant speed. Okay, fine. When first sighted at 9, S is a point with position vector that relative to the fixed origin. Okay, so let's represent where it is at the moment at 9. Okay, so back to down 4. This is S at 9. Okay, now where's it at 9:40? Well, it goes across 4 and down 6. Okay, so relative to the origin, here is where it is at 9:40. That's where S is at 9:40. Okay, calculate the bearing on which S is drifting. Okay, so this is, do we remember bearings from GCSEs? Okay, well, key thing about bearings is you need to do a north from where it's from. Okay, so it's drifting from 9 to 9:40. Okay, it's got to start at the earliest time, so that's how we know it's from here. Now, bearings is this clockwise angle. Okay, what is this angle? Okay, well, we can figure out this angle by using SOHCAHTOA. Okay, but then we don't know if we can figure out this angle yet. Okay, so instead, what we're going to do is we're going to draw a horizontal line here. Okay, so it's because we know this angle is greater than 90 degrees. We make this 90, then we've only got to figure out one angle. Okay, and this one angle is inside this triangle. Okay, and this triangle we do know the dimensions of. Okay, because it's across by 6, and 6 take away 4 is 2. Okay, so we know the dimensions of this triangle, so we can then calculate this angle. Let's call that x. Okay, so using SOHCAHTOA, we've got opposite and our adjacent, so then we've got x being the tan inverse of 2/6, so x is 18 degrees. Okay, but we didn't want x as 18 degrees, well, we did want x at 18 degrees, sorry, but they weren't asking what x is, they're asking for the bearing. Okay, so therefore, that's what the 3 dots mean. Therefore, the bearing is our 90 degrees plus our 18 degrees, this full angle here. Okay, that's from 108 degrees. Next, we need speed. Okay, and whenever you're asked for speed, this formula should just jump out to you. Okay, it should be instinct at this point. Okay, speed is distance over time. Okay, we know our time. Okay, so let's write it down straight away. We know our time. Okay, and let's do this in hours. So 40 out of 60 hours. Okay, so 2/3 hours. All right. Now distance. Distance is the harder one to calculate. Okay. Distance is going to be this drift. Okay. This vector drift is what we want to find the distance of, because that's the speed that S is traveling. Okay. And we can find this using our 2 initial vectors. Okay, but that diagram is quite confusing. So let me rewrite what we had. Okay, so we had -2, -4 from the origin. And then we had 4, -6 from this origin here. Going this way, going this way. And then our drift here, we'll label D, is kind of the path that S is taking as it drifts. Okay, so what is D? What is this D? Okay, well, it's -2, -4. All right, because we're going against the flow in the opposite direction. And then we're adding 4, -6. Okay, so we got 2 plus 4, 6. 4 take away 6. Okay, so this is our vector for our drift, but we want to find the distance that it drifts. Okay, so we have, using Pythagoras' theorem, we get, this is root 40. This is skipped a few steps there. Root 40, 4 times 10, 2 root 10. Okay, so going back to our speed is distance over time. We know our distance, which is 2 root 10. Okay, what is our units we're using here? Well, we've got kilometers. Okay, so this is 2 root 10 kilometers. Okay, so 2 root 10 over 2/3. Okay, that was our time. This is 3 root 10 kilometers per hour. Okay, and as this is physics, okay, we don't want to leave it as a surd. Instead, I'm going to put that in my calculator, and I'm going to get kilometers per hour. And that is your final answer.